Hello students, welcome to Genesis Coaching Institute, Bazar, Guwahati. I am a maths faculty from Genesis. So today we are going to discuss the two-dimensional geometry, the coordinate geometry. What is coordinate geometry? So actually the coordinate geometry is the combination of geometry and algebra. Okay. So here we will discuss the coordinate geometry, that is the intersection of geometry and algebra. So this is the combination of coordinate geometry. Okay. Next we are going to discuss the important system, that is the rectangular coordinate system. What is the rectangular coordinate system? So what is the rectangular coordinate system? The rectangular coordinate system is formed by the intersecting two perpendicular lines. So this is called, the horizontal number line is called, that is x-axis. Okay, and the vertical number line is called y-axis. So what is the intersecting point here? These two lines intersecting at the point O. So this is called origin, right? So now here from the right side of origin we take the positive numbers, like here 1, 2, 3. Okay, then left hand side, that is negative, -1, -2, -3. The above x-axis they are positive, here +1, 2 and 3 dash dash, and below the x-axis that is -1, -2, -3 dash dash. So this is called rectangular coordinate system, or we call the Cartesian plane also, right? Now how do you find the rectangular coordinate system here? So we can represent every point. We can represent every point. Suppose, see here, this is a point Px comma y. It is represented an ordered pair. Okay. So here, what is x here? Here the first number of an ordered pair is called x coordinate or abscissa. See here, this is called abscissa or x coordinate. The second number of an ordered pair, that is called y coordinate, or we call simply ordinate. Okay students, understood all of you? So this is the rectangular coordinate system. Then why it is called the rectangular coordinate system? See here, these two lines, these two axes, the angle formed by these two axes at the origin is 90 degrees. Okay, so these two, the angle formed by these two axes at the origin is 90 degrees, and also here the angle formed, the measurements at the point P is also 90 degrees. That's why it is called a rectangular coordinate system. Okay. Then next here, it consists of 4 quadrants. Okay. What are they here? The quadrants are, namely, we can use the Roman numerals. That is 1, this is second quadrant, this is third quadrant, this is fourth quadrant. Okay. So now we can begin with top right quadrant. Okay, moving anti-clockwise direction. So this is the first, second quadrant, third quadrant and fourth quadrant. Okay, what about here? On the x-axis here, on the x-axis here, y coordinate is 0. Okay, on the x-axis here, y equal to 0. What about y-axis here? On the y-axis, here x should be 0. Okay, right. Now In the first quadrant, the signs are both are positive. See here x and y both are greater than 0. Here x greater than 0 and y greater than 0. Therefore, here plus comma plus. We can use the symbols. Here signs are both are positive. First coordinate and second coordinate both are positive in the first quadrant. What about in the second quadrant? Here in the second quadrant, here x will be negative and y should be positive. So here x is less than 0 and y greater than 0. That's why here we can use the signs here negative and positive. In the third quadrant, both are negative here. X less than 0 and y less than 0. Therefore, minus comma minus. And the last quadrant, in the fourth quadrant, here x is greater than 0 and y is less than 0. X greater than 0 and y less than 0. Here the signs are positive comma negative. So this is the rectangular coordinate system. Okay, understood all of you. So the next we will discuss some basic topics. Okay, we will discuss the first topic. What is the first one here? The distance between 2 points. 2 points. Okay. So these are coordinate axes. This is x axis and it is y axis. Okay, so this is the origin. Now, what is origin here? Origin means here that is 0 comma 0. Okay, now we can take any point P here. Suppose let it is P x comma y. So here the point P x comma y, here x represent here how much distance from the x axis and how much distance from the y axis. See here, this point P, y units distance from x axis. Okay, y units distance from x axis and x units distance from y axis. So then it is called the point P x comma y. Here x represents that is x distance from y axis and y represent here y unit distance from the x axis. Okay, now I want here the distance between the origin to the point P x comma y. Okay, now we can join these 2 points. So we got here one of the perpendicular, here right angle triangle. See here, suppose let it is Q. So here right angle. So here triangle OPQ is a right angle triangle. Right angle triangle. So we know the Pythagoras statement. What is the Pythagoras statement here? Pythagoras statement is the hypotenuse square equal to the sum of the squares of adjacent side. So that means here OP square equal to that is OQ square plus PQ square. So now tell me students here, what is OQ? OQ means that is this distance is equal to x, okay, from the y axis, OQ. Then next, what is PQ here? From the x axis, the distance is y, that is PQ. Now we can substitute here, what is OQ? OQ is x, so that is x square plus PQ, that is y square. So OP square equal to x square plus y square. Then what is OP here? OP equal to square root of x square plus y square. So this is the distance from the origin to any point P on the plane. Okay, right. Now I want here the distance between any 2 points on the plane. How we can find the distance between any 2 points on the plane? So here again I am taking here the 2 coordinate axes x and y. We let 2 points on the plane. One of the point here P x comma x1 comma, let it is x1 y1, okay, and let another point Q, that is x2 comma y2. Okay, now we can join these 2 points. Now I want the distance between these 2 points. We want here PQ distance. How we can find the PQ distance? See here, we can draw the line which is parallel to x-axis from the point P, and from the point Q we can draw one line which is parallel to y-axis, and again we can draw 2 perpendicular lines. Suppose let the point is, the intersecting point is, let it is R, and we can draw 2 more perpendicular lines from P and R on the x-axis. So let it is A and it is B. Okay. Now tell me students here, the point here, what is point P here? X1, Y1. So what is the distance OA? So here OA represents, that is X1. Okay, so this is equal to X1. OA distance is equal to X1. Now what is AP? Here AP represents here Y1. So this is Y1 distance from x-axis. So here see, observe here, PA and RB both are equal. So therefore here PA and RB both are same. This is also Y1. Next, now here QX2 comma Y2. Here what is X2? X2 means here from the y-axis. Okay, from the y-axis, how much distance here? X2 distance. That means from origin OB, here OB distance is equal to X2. Okay, and QB, that is equal to Y2. Now I want here AB distance. How we can find AB distance here? See here, AB equal to, here AB equal to total distance minus OA distance. Total distance means OB minus OA. So that equal to X2 minus X1, right? The next I want here QR distance. So QR equal to total distance, that is QB minus RB. So now here what is QB? Total distance, that is Y2 minus RB, that is Y1. Now here AB distance, we got AB distance is X2 minus X1. So this is equal to PR distance, therefore this is X2 minus X1. Okay, and we got here QR. What is QR here? Y2 minus Y1. So this is a right angle triangle. Now we can apply the Pythagoras statement. So here AQ square equal to that is PR square plus QR square. Now what is PR square here? What is PR? PR means X2 minus X1 whole square plus QR. What is QR? Y2 minus Y1 whole square. Then I want here AQ. Here square become, that is square root of X2 minus X1 whole square plus Y2 minus Y1 whole square. So this is the formula to find the distance between any 2 points on the plane. Okay, understood. So these distance formula we can use many problems. In the many problems here, how we can use this formula in further problems here? See here, suppose they given 3 points. We can show that the 3 points are collinear. Then simply we can take here AB plus BC equal to AC. AB distance plus BC distance, this is equal to AC distance. Then the given 3 points are A, B, C are collinear. Okay, and also this formula we can use to find the circumcenter also. Okay. Now next we will discuss the second one, that is the area of triangle. We are going to discuss the area of polygon. Area of polygon. Suppose they given 3 vertices. Okay, AX1 comma Y1, BX2 Y2 and C x3 comma y3. These three vertices of a triangle. So we want here the area of triangle ABC. Okay, then how we can find the area of triangle? So here we can use the formula, that is the basic formula here, of into mod of x1 y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, so this is the formula to find the area of triangle. Next one, and also we can use by using the determinant also we can find the area of triangle. See here, half into, simply we can write the first row here x1 y1 1 and second row x2 y2 1 and third row x3 y3 1. Okay, by using determinant we can also find the area of triangle. Otherwise, one of the formula, another formula is also there, that is stair method. Stair. So what is this here? Simply we can take here also we can take the same determinant here, half into, here we can use two columns. The first column we can write here x coordinate, that is x1, x2, x3 and repeat here x1, the last one. And in the second column you can write y coordinates, y1, y2, y3 and the repeat here y1 coordinate. Then next you can take the difference of the product of 2 by 2. So first you can take the difference of these two product. Okay, so that is half into x1 y2 minus x2 y1. Okay, next you can use the symbol here positive sign. Then next here take the product of difference of these 2 by 2. So here x2 y3 minus x3 y2 plus, then after here use here you can take the difference of the product of difference of these two, x3 y1 minus x1 y3. Like this we can use this formula to find the area of triangle. Suppose they given n vertices, we want here the area of polygon. How we can find the area of polygon? By using stair method, simply we can find the area of polygon. So that is here a, b, c, x3, y3 and d, x4 and y4 dash dash, xn and yn. So here they given n vertices. Now we want here area of a polygon. By using stair method, now we can write here half into here, write the first column, that is x coordinate only, here x1, then x2, x3 dash dash, the last one xn and repeat again here x1. Next here y1, y2, y3, yn and repeat again y1. Like this we can take the product of difference of 2 by 2 1 by 1, then we get the area of polygon. Okay, this is the second one. The next third one, that is a section formula. Section formula, here we can arise two here, two are there, two formulas are there. One of the formula for internal division and the formula for external division. The third one, that is section formula. So first one, the formula for internal division. The formula for internal division. So what is the formula for internal division? Here the coordinate of a point, suppose the point is px comma y, okay, this point can divide joining the 2 points. See here, this is a point px comma y, this can divide the line segment, so here a x1 y1 and b x2 y2. This point px comma y can divide the line segment joining a x1 y1 and b x2 y2 in the ratio ap east pb internally. Suppose here the ratio, let it is m, here n. So here the point p x comma y can divide the line segment joining these 2 points internally in the ratio m is to n. What is the formula to find the formula for internal division? That is px comma y equal to mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. So this is the formula to find the internal division. Here this point px comma y can divide the line segment joining these 2 points internally in the ratio m is to n, then that point px comma y equal to mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. How we get the here that formula? So here the proof is, suppose here we get the same, here 2 coordinate axis, this is x axis and it is y axis, it is origin. Now take the line segment joining the 2 points, let it is point A x1 comma y1 and this point B x2 comma y2, okay. So here the point P, that is x comma y, this point P can divide the line segment joining these 2 points internally in the ratio AP is to PB, that is M is to N, okay. Now we can draw 3 perpendicular lines from A, P and B on the x axis. So this is one of the perpendicular line, okay. So these are 3 perpendicular lines from the point A, P and B on the x axis. Here respectively, let it is L, this is M, this is N. Okay. Now again we can draw 2 perpendicular lines from the point P on the line BN. The next one here from the point A on the line PM, let it is Q, this is R, okay. Right, see here the triangle ARP, the triangle ARP, comma the triangle PQB are similar triangles. Why? Similar triangles. Why? Here, see here, angle here R, here angle R is 90 degrees, here also 90 degrees, both are equal, and also here the corresponding angles, here the corresponding angles are also equal. So therefore here this triangle ARP and PQB both are similar triangles, okay. Now here you can take the ratio AP is to PB, that means AP by PB, that equal to AR by PQ, that equal to PR by BQ, PR by BQ. Now tell me students here, what is AP and PB? Here AP is M and PB is N. Now I want here AR and PQ. Okay, so here OL, what is OL? OL distance is equal to x1, this is x1, and next one here AL distance, that is equal to y1, so this is also y1. Okay, now here what is OM distance? What is OM distance? That is equal to x. Then next here what is ON? ON distance is equal to x2. Okay, right. Now then here BN distance is equal to y2. Okay, then now tell me students, what is LM? Here LM distance equal to OM distance minus OL. What is OM? X, and what is OL? X1. So this is equal to X minus X1. So this is equal to AR. So this is also X minus X1. Then next here what is PQ? PQ means what is MN? MN means here ON. What is ON distance here? X2. And what is OM here? X. So that means here X2 minus X. So here MN is equal to PQ. So this is equal to X2 minus X. Okay. Now what is BQ and PR? Now here PR. What is PR here? Now tell me here PR means here. So this distance equal to, what is here? PM distance equal to Y. Okay, now I want here PR. What is PR distance here? Total distance Y, and here RM distance is Y1. So Y minus Y1. Then next here total distance is Y2. Okay, now here I want here BQ distance. So BQ distance, how we get the BQ distance here? From the difference of BN minus PM, that is Y2 minus Y. So this is equal to Y2 minus Y, that is BQ distance. Now we can substitute one by one. We get here AP, that is M, by BP, that is N, equal to AR. What is AR here? AR X minus X1, and PQ. What is PQ here? X2 minus X, and that equal to PR. What is PR here? PR. So here P and R. So here Y minus Y1 by BQ, that is Y2 minus, sorry, here Y2 minus Y only, not Y1. Y2 minus Y. Okay. Now take the first two ratios. So here M by N equal to X minus X1 by X2 minus X. Then you can do cross multiplication. You get here MX2 minus MX equal to NX minus NX1. Now minus NX1 take left side, that become positive, and minus MX take right side, that become positive. So now we get here MX2 plus NX1, that equal to MX plus NX. Here minus MX become plus MX. Take here X common. So then X of M plus N. Now I want here X coordinate. So then X equal to MX2 plus NX1 by M plus N. So this is equal to X. Similarly, equating these, first and last one, then we get Y equal to My2 plus Ny1 by M plus N. So this is the formula for internal division. So what about the second one? The second one, that is the formula for external division. How we can find the external division formula? Simply students, here we can replace here positive, here negative sign, then we get the formula for external division. Okay, now tell me what is the formula for external division here. Formula for internal division, simply you can use here positive sign. Okay, if we want external division, you can replace positive with the negative sign. Okay, then tell me here, what is the formula for external division? Formula for external division, that is px comma y equal to mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n. Okay, so this is the formula for external division. So in sometimes for the sake of convenience we can take the ratio lambda is to 1. Okay, lambda is to 1. In sometimes we can take the ratio. This is better to find the point. Okay, so what is the formula here? Px comma y equal to, here this is m, this is n, then mx2 means here lambda x2 plus nx1 means that is 1 into x1 by lambda plus 1, and my2 that is lambda y2 plus ny1 that is y1 by lambda plus 1. Okay, if lambda turns out it positive, then we can take the internal division. Suppose the lambda turns out be negative, then it takes the external division. Okay, that is depending upon lambda value. If the lambda turns out the positive, then we can take the internal, we can apply the internal division formula. Okay, otherwise external division, right? Suppose here lambda is equal to 1. What about here? If lambda is equal to 1, that is 1 is to 1, then so this is the point A x1 y1 and this is the point B x2 y2. Now here the point P can divide the line segment, these two, joining these 2 points A and B in the ratio 1 is to 1. That means the point P is the midpoint of A and B. Okay, so now we can substitute here lambda equal to 1. Now we get here the point P x comma y. So that equal to 1 into x2 means x2 plus x1 lambda. Here what is lambda here? 1, 1 plus 1 that is 2, comma y2 plus y1 by 2. So this is the formula to find the midpoint of 2 points A x1 y1 and B x2 y2. Understood, students here? Okay. Now in this lecture we discuss the distance between the 2 points. What is the distance between the 2 points? The formula is the square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula to find the distance between any 2 points AB. Okay. The next one, area of polygon. Here area of polygon, we can find area of a polygon. Here we have 3 formulas are there. So one of the formula, that is directly we can apply half into x1 mod of x1 of y2 minus y3 plus x2 of y, here half into, okay, half into mod of x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. Okay, or we can apply here a determinant also. By using determinant we can find the area of triangle, or by using stair method also we can find the area of triangle. Suppose the given n vertices, then we can apply the stair method easily to find the area of polygon. Okay, the next one, the section formula. Here section formula, here we have two formulas are there. The first one is the formula for internal division, the next one external division. What is the internal division? That is px comma y equal to mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. The next one here, the formula for external division, that is px comma y equal to, here simple you can use the in the replace of a positive sign, here negative. Okay, then we get the external division formula. The next one, in sometimes we can take the ratio for the sake of convenience, here lambda is to 1, then apply here section formula, we get this one. Okay, if the lambda value turns out to be positive, then we can apply internal division, otherwise we can apply external division. Okay, then if lambda equal to 1, the ratio is 1:1, then the point P x comma y can divide the line segment these 2 points in the ratio. Same ratio means that point is midpoint of A and B. Okay, what is the midpoint formula we get here? P x comma y equal to x1 plus x2 by 2, y1 plus y2 by 2. Okay, so many topics are there here, many basics are there, but the coordinate geometry, these basics are very important, students. Okay, so further topics are depending upon these formulas, and centroid, incenter, circumcenter, orthocenter, many more. Okay, so we will discuss later. Then thank you. Okay, see you, bye.